Question 3. I've got some numbers. Maths after all, you know. Okay, so list numbers, and we want to use the first fit bin packing algorithm to determine how many of the numbers listed can be packed into bins of size 3. Alright, so first fit is dead straightforward. You literally just put the number in the first bin that it fits in. Alright, so I'm aiming for bins of size 3. So I'm just going to write that side. Oh, this is part A. Don't forget to put the part down so you know which one you're doing. So our bins are of size 3. Alright, so the 1.1 can obviously fit in the first bin because the first bin's empty. 0.7 can also fit in that first bin because it's got to go up to 3. So I've got 0.7 taking that bin up to 1.8. Now, tick these off as we go. Now the 1.9 is not going to fit in that first bin because it would be too full. So we create a second bin and we're going to put 1.9 in that second bin. Okay, 0.9 will go back into the first bin, so does 0.9 fit in the first bin? Well, yes it does. So we put the 0.9 in there, taking that up to a capacity of 2.7. Okay, 2.1 won't fit in the first bin, won't fit in the second bin, so we draw bin number 3 with 2.1 in. Obviously these are numbers, the scale's not quite right, but it doesn't really matter. Okay. 0.2, the first bin's got 2.7, so I can fit a 0.2 in. So I've got 0.2 in there, taking that one up to a capacity of 2.9. 2.3 won't fit in the first, won't fit in the second, won't fit in the third, so we get a brand new bin 4, 2.3. Okay, 0.4 won't fit in the first, but it will fit in the second, so 0.4 ends up there. That takes this one up to 2.3. 0.5 won't fit in the first bin, but it will fit in the second bin. 0.5 takes that one up to 2.8. And lastly, 1.7 won't fit in the first, won't fit in the second, won't fit in the third, it won't fit in the fourth. So it goes into bin number 5. Don't forget then just to list what you've got in each bin. So bin 1, I've got 1.1, 0.7, 0.9, 0.2. Bin 2, I've got 1.9, 0.4 and 0.5. Bin 3, I've got 2.1. Bin 4, I've got 2.3, is that? Yep. And bin 5, I've got 1.7, which I didn't tick off as I was going. Okay, so 5 bins altogether. Let's just check if we've done everything. The first fit bin packing algorithm to determine how many of the numbers can fit into bins of size 3. Spot on, we found that it was 5 bins. Okay, next part. The list is to be sorted into descending order, starting at the left-hand side of the list. Perform one pass through the list using a bubble sort. Write down the list of results at the end of your first pass. Because I'm clever, I'm going to read the second part of that question because that wants me to write down the number of comparisons and the number of swaps during your first pass. So what I'm going to do is I'm actually going to keep track of that for part 2 as I'm doing it, just to make life a little bit easier. Okay, so it only wants one pass. We only need to write down the results at the end of the first pass, so it is literally just like, obviously, the question and then the one line of working out. We don't have to write down all of the individual bits. So this is now part B. I'm just going to write the list of numbers down again. So I've got 1.1, 0.7, 1.9, 0.9, 2.1, 0.2, 2.3, 0.4, 0.5 and 1.7, so that is my original list. Okay, I'm doing part BI here where I'm just doing it, but at the same time I'm going to keep track of my comparisons using a tally chart, and I'm going to keep track of my swaps again, just using a tally chart just to save you working it out after. I want to go in descending order, which is getting littler, starting at the left hand side. Okay, so first off I'm comparing the 1.1 and the 0.7. So I've done a comparison. I find that they're in the right order, they're already in descending size, so I leave the 1.1 there and the 0.7 kind of bubbles forward. Okay, so I'm now comparing the 0.7 and the 1.9. So comparing. They're in the wrong order, so I'm going to swap them. So it means the 1.9 ends up on the left and the 0.7 kind of bubbles forward. So I'm now comparing the 0.7 and the 0.9, is that? Yep. So 0.7 and 0.9, they're in the wrong order, so I need to swap them. So that means I've got 0.9 here, 0.7 carries forward. Okay, I'm now comparing the 0.7 and the 2.1. They're in the wrong order, so I need to swap them. So I've now got 2.1 and the 0.7 still kind of going forward. So I'm now comparing the 0.7 and the 0.2. So I'm comparing. They're in the right order, so I don't swap them. So 0.7 goes there. Okay. Comparing the 0.2 and the 2.3, so they're in the wrong order, so I need to swap them. So that's going to be 2.3, 0.2 goes forward. Okay, comparing 0.2 and 0.4, they're in the wrong order, so I need to swap them. So yeah, no. So yeah, so apparently I can't decide which number is bigger. So 0.4. Apologies there. All right, so I'm now comparing 0.2 and 0.5 again. So I've compared them, and they're in the wrong order. So that leaves me with 0.5 here. 0.2 goes forward. Lastly, comparing the 0.2 and the 1.7. They're in the wrong order, so I swap them. So that leaves 1.7, and the 0.2 has ended up at the end, which it should do, obviously, because it is the smallest. Okay, so that is part B I done, and then just add up for the second part. I've done 9 comparisons and 7 swaps. Okay, back to the question. So I've done that, and I've done that. Okay, after a second pass, the updated list is this. Use a quick sort to do this updated list, making my pivots clear. Okay, so I need that new list. So I'm just going to quickly, it's hard for me because I'm going in between. So 1.9, 1.1, 2.1. So just bear with me for a second. 2.1, 0.9, 2.3, 0.7. 0.5, 1.7, 0.4, 0.2. 0.5, 1.7, 0.4 and 0.2. Obviously just be careful when you're doing that, make sure you've got that you copy that right. Right, so I'm now doing a quick sort. So my first job is to find my pivot. Now my pivot is the middle number. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. Okay, so really it's like the 5.5 number. I always take the right hand side of it, but as long as you are consistent, it shouldn't matter. So I'm going to take the 6th number, which is this 0.7. If you've chosen the 2.3, that is fine, but like I said, just make sure you always choose the left hand side where there's a choice there. So I'm going to just write the 0.7 on the next line, because that one is now fixed in position. So I'm going to put it in a square box. It tells me that it can't move. We now go through left to right and decide which side of the 0.7 they're going to go on. 1.9 is bigger, so it needs to be on the left of the 0.7. 1.1 is also bigger. Make sure you're writing these in the right order as you do it, like left to right, sorting from there. 2.1 is also bigger. 0.9 is also bigger. 2.3 is also bigger. 0.5 is smaller, so again on the left hand side, like on to the left of the right hand side. 1.7 is bigger, I'll just squeeze it in there, and 0.4 is smaller, 0.2 is smaller. So after one pass it looks like that. Alright, I now need new pivots, and remember you do the left hand side and the right hand side at the same time. Now I've got 6 numbers on the left, so it's like 3.5, I round up, so I've got the 4th number. So again I've chosen the right hand side of that. This one, it's obviously the 0.4 in the middle there. So on the next line I've got the 0.7 in fixed position, that can't move because it's already in a box. I'm also going to get the 0.9 in a fixed position. So I'm just going to draw that into a box, and I'm going to get the 0.4 into a fixed position. Alright, so looking at the left hand side, so I'm sorting around the 0.9. 1.9 is bigger than it, so it goes on the left. 1.1 is bigger, it goes on the left. 2.1 is bigger, it goes on the left. 2.3 is bigger, it goes on the left. And 1.7, again, just squeezing it in there, is bigger, so it goes there. Now sorting the right hand side, so starting with the 0.5, 0.5 is bigger, so it goes on the left. 0.2 is littler, so it goes on the right. Okay, I now need to pick new pivots. I've got the 0.2 and the 0.5. I mean, they're already in a list of 1, but just to sort of, you know, bring it through and do that. On this one, I've got 5 numbers, so the 1 in the middle is the 2.1. So on the next line, the 2.1 is now going to be fixed in position, so I'm going to draw that in the box. I've got the 0.9 is going to be fixed in position, or it still is from there. 0.7 is fixed. 0.5 is now newly fixed because it was a pivot on the last line. So all of these are kind of in the right position. Same with the 0.2 there. Okay, so I'm just looking at this left hand side now. 1.9 is smaller than 2.1, so it goes here. 1.1 is smaller, so it goes there. 2.3 is bigger, so it goes there. 1.7 is smaller, so it goes there. Okay, keep pivoting. So I've got those two new pivots now. So on the next line, I've got the 2.3 is in fixed position. I've got the 2.1 is in a fixed position. The 1.1 is going to be in a fixed position. And then all of these rest of them, 0.9, 0.7, 0.5, 0.4, 0.2. Again, they're all in fixed positions as well. Right, so I've now just got the 1.9 and the 1.7 to sort out. 1.9 is going to go on the left, as is the 1.7. And obviously we can see that my list is now in the right order, but I'm not done yet because it's D1. We'll get to do lots of extra working out. So 1.7 is my next pivot. So that means I'm going to get, on the next line, I've got the 2.3 and the 2.1 are both in the correct position. I've got everything from the 1.7 downwards is now going to be in, oh, hang on, can't connect that on that text, but 1.1, 0.9, 0.7, 0.5, 0.4, 0.2, they're all there. Don't know what sound effects are for, sorry. Yeah, so 1.7, actually, that should be in a box because that's now there. So it's just the 1.9, I can see that it is going to go on the left because it is bigger. That's now a pivot. So then last line is everything is going to be sorted. So 2.1, 1.9, 1.7, 1.1, 0.9, 0.7, 0.5, 0.4, and 0.2. Now everything's in the right position because obviously the 1.9 would be in the box. I'm not going to bother drawing the boxes around everything, but I am just going to do a quick sort of, list is sorted, obviously. And let's go back to the question for a second. So we used a quick sort, we made our pivots clear, so we'll do a nice tick. And lastly, apply the first fit decrease in bin packing algorithm to my fully sorted list to pack the numbers into bins of size 3. So first fit decreasing is where you have them in decreasing order of size, which we did in part C, and it's then just, did I label that as part C? Oh, I didn't, that was naughty, that should be part C. Apologies for that. So now part D. So I'm going to put them in the first bin that they fit in. I'm not going to draw the bins this time. I'm just going to go straight into kind of doing the bin one, combining it like that. Right, so 2.3 goes in the first bin. 2.1 will not fit in the first bin, so it goes into a second bin. 1.9 will not fit in the first bin, will not fit in the second bin, so it goes into a third bin. 1.9. 1.7 doesn't go in the first, the second, or the third, so it goes into a fourth bin, 1.7. Okay, 1.1 doesn't fit in the first, doesn't fit in the second, but does fit in the third, taking that up to its maximum capacity of 3. 0.9 doesn't fit in the first, but does fit in the second, so I've got 0.9 there. 0.7 fits in the first. 0.5 doesn't fit in the first, so it can't fit in any of the first 3 because it's full, but it will, however, fit in this third bin, taking that up to 2.2. 0.4 will also fit in that fourth bin, taking that up to 2.6, and then the 0.2 will also fit in there. So there we go, I have now packed that into 4 bins. Fully sorted, packed in bin size 3, tick. 14 lovely marks for that question.